In our project, we wanted to control an LED strip by using Alexa. The LED strip should be able to get turned on or off. We should set the brightness of the LED strip, the colors, and we should also do modes. So we can talk to Alexa and it will turn the LED on. So it's getting on. We could tell Alexa to switch colors, and we could also tell Alexa it should set the brightness. Now it should get darker. And now we switch back to brighter lighting. And we should, of course, also turn it off.
And now to the contents of the presentation. Right now we saw a short project overview and showed the expectations, what the project should be able to do. From now on I will talk about the components a bit and show the development process, and in the end you'll see a demonstration of our final project results. As components we used an Echo Dot with the Alexa smart home assistant, which should send the commands for the LED control and which currently supports Matter, which is currently in development for the Alexa. We also use the ESP32 microcontroller, which acts as the interface between the Alexa and the LED strip. We use the Matter smart home implementation, which is a protocol to send the data from the Alexa to the ESP. And we also used a WS2812 LED strip, where every LED is individually addressable, so we can show different colors or different brightnesses on separate LEDs. The ESP32 is a microcontroller which is produced by Espressif. It has integrated Wi-Fi, Bluetooth, and ultra-low power processor, it has security features, and so on. We'll use the Matter over Wi-Fi implementation for that because it doesn't support Thread or Zigbee, because it doesn't have the right transmitter on board. In the future, we want to use the ESP32C6, which includes Threadbee and Zigbee transmitter, which has special features. It makes it possible to use it as an open thread border router, which is a Matter feature which will become handy in the future. Matter is the standardized smart home protocol, which is fast growing and highly compatible between manufacturers because it's made by a collaboration of many companies, and the data model is based on the Zigbee cluster data model. The metadata model is a hierarchical structure which starts at the device and goes down to endpoints, which divide the device in logical divisions. The first endpoint, endpoint 0, contains general information about the device, and the other endpoints contain information about what it is. For example, the endpoint 1 can control a light, and the second endpoint can control a thermostat, for example. The endpoints contain of clusters, which have different functionalities, and each cluster has attributes and commands, which can manipulate the data in the same or other endpoint of the same or another device. The metadata model has a server-client binding, which means that clients can connect to servers and send commands or change attributes at the server. It's also possible to connect multiple clients to a server so that many devices can control another device. Now, coming to connecting all the devices together, it will look like this. At first, we connect the Alexa to the ESP via the Matter standard, and the ESP has a LED driver which acts as an interface between Matter and the LED strip, and the LED driver is based on the LED strip library provided by the ESP IDF 5.0. Our data model contains out of 2 endpoints, the endpoint 0, which contains general data of the device, like the device name, the manufacturer, and the endpoint 1, which contains the controls over the lights, like the on-off cluster, the level control cluster, and the color control cluster. We will represent the modes by color temperatures because the Matter specification 1.0 doesn't specify the scene cluster yet, and we'll bind the Alexa to the ESP, which then will control the clusters, and it's also possible to connect multiple devices to the ESP. To control the LEDs, we had to write an interface between our Matter implementation and the LED strip library. We used to control the LEDs the ESP IDF 5.0 LED strip library, and also implemented the static and waves mode, which is controllable via the color temperature settings provided by Alexa. Alexa, Tischlicht an.
Okay.
Alexa, Tischlicht auf 50%.
Okay.
Alexa, Tischlicht weiß.
Okay.
Alexa, Tischlicht kalt weiß.
Okay.
Alexa, Tischlicht warm weiß.
Okay.
Alexa, Tischlicht rot.
Okay.
Alexa, Tischlicht kalt weiß.
Now we want to add why we are using the Meta standard to make this project. We use it so our LED strip is controllable by any other Meta controller or Meta device. We don't need Alexa, so we could also control it by a light switch, a remote, an app, or anything else. Also, Meta provides device-to-device automation, which means we have no need for a smart home assistant, but we can connect devices directly without using an intelligent smart home assistant between it. So we could, for example, connect a light switch directly to our LED strip.